Today, we're going to break down a really revolutionary new method for AI self-improvement. It's a framework that lets a single AI model create its own private training academy, pushing its own limits way beyond what we thought was even possible. So, how does it work? Let's dive right in.
So this is the big question, right? It's the fundamental challenge facing pretty much all of AI development. I mean, if an AI only learns from data that humans created, how can it ever really, truly get smarter than us? It's a puzzle that gets right to the very core of AI's potential.
And that question leads us straight to this problem, the human data bottleneck. You see, traditionally, we train AI models on these gigantic, human-made data sets. And that process, it's expensive, it's super slow, and, most importantly, it fundamentally caps the AI's knowledge to what we humans already know. It creates a ceiling.
Well, to smash through that ceiling, researchers came up with a framework called Multi-Agent Evolve, or MAE for short. And honestly, the best way to think about it is as a self-contained, self-improving training academy that's run entirely by the AI for the AI.
Now here's what's so cool about this. This entire system, this whole academy, is powered by just one large language model. It basically splits its own consciousness, so to speak, into 3 different parts that all interact and work together to get smarter. All right, so let's meet the staff of this AI academy. They are the proposer, the solver, and the judge. And each one has a super specific and absolutely crucial job to do in this whole learning ecosystem. First up, we have the proposer. Think of this one as the professor or the curriculum designer. Its entire job is to cook up new, interesting, and really difficult questions that are going to push the boundaries of what the AI can currently handle. Next, we've got the solver. This is our student. The solver's role is pretty straightforward. Take the questions that the proposer just made up and try to answer them as best as it possibly can. This is the part of the model that's actually doing the learning. And finally, we have what might be the most important role of all, the judge. The judge is the grader, but it doesn't just check the solver's answer. No, it also grades the proposer's question. This two-way feedback is the secret sauce that makes the whole system work. And here's what that process looks like. It's just a continuous, self-sustaining loop. The proposer makes a problem, the solver tries to solve it, the judge gives feedback on both, and then the whole system learns from that feedback and does it all over again, getting just a little bit smarter each time. But it's not just some simple loop. It's actually a super dynamic game. The roles are designed to be in this state of cooperation and competition at the same time. The paper calls it co-evolution, and it's this healthy tension that really fuels the AI's growth.
So check this out. The proposer is constantly trying to come up with questions that are just hard enough to stump the solver. Meanwhile, the solver is constantly training to get good enough to answer anything that gets thrown at it. It's kind of like an arms race, and it forces both of them to get better and better.
So how does the system know what better even means? Well, it's all based on a clever reward system. The proposer gets points for making good, tough questions. The solver gets points for getting those answers right. And the judge? Well, the judge basically gets rewarded for being a good, fair referee.
The judge also has another really critical job. It's the gatekeeper. To make sure the training data doesn't get filled with junk, the judge just throws out any question that it thinks is low quality. In the study, any question that scored below a 0.7 out of 1 got tossed, which keeps the curriculum really strong. Okay, so after all of this self-teaching, this co-evolution, here's the billion-dollar question. Did it actually work? Did the AI actually get smarter? Let's take a look at the results. And the answer is a huge, resounding yes. As you can see right here, the model trained with this multi-agent evolve framework, that's the bar on the right, showed a really clear performance boost compared to its original version on the left. And this was across a whole range of tests. To put a number on it, the paper reports an average improvement of 4.44% across different tests covering things like math, reasoning, and general knowledge. Now that might not sound like a huge number, but in the world of AI benchmarks, trust me, that is a significant leap. But here's where things get really wild. The researchers decided to compare their MAE method, where the AI had no answer key at all, against the standard way of doing things, which is called supervised fine-tuning, or SFT. That's where you train a model on questions and their human-verified answers. And this is the absolute killer finding from the paper. The AI that taught itself, the one that generated its own curriculum from scratch with no cheat sheet, actually performed better than the AI that was given the answer key. It learned more by struggling through its own problems than by just memorizing our answers. So what does this all mean for the future?
Well, the implications are just massive. This could really point to a whole new way of thinking about how we build artificial intelligence.
You know, what we're looking at here isn't just a cool experiment. It's a potential blueprint for finally breaking that human data bottleneck we talked about. It gives us a path to creating AI systems that can just keep learning and improving on their own, without needing us to hold their hand the whole time.
And that leaves us with a pretty fascinating question to chew on. If an AI can effectively design its own education, if it can figure out what it needs to learn to grow, what new frontiers of knowledge is it going to explore? What will it decide to teach itself next?